In our section today, we're going to focus on operations with rational functions that will include factoring, multiplying, and dividing. We're also going to talk about a new idea called restrictions. And restrictions are values of x or y or whatever variable we are using that will make the denominator of the original expression 0. And we need to avoid these numbers. So in many of our cases today, we're going to be looking to factor out a GCF, and then cancel those factors. So let's begin. Our first problem is x squared plus 6x plus 5. Very quickly, you can realize that this factors to x plus 5 and x plus 1. The denominator factors to x plus 5 and x minus 5, which is the difference of two squares. Our factors in the denominator are 5 and negative 5 that would make our restrictions. So I'm going to put those over here. X cannot be 5 or negative 5 as our two restrictions for this original problem. In our original problem, we see the x plus 5's cancel, and that leaves us a final answer of x plus 1 over x minus 5. So we're going to factor, cancel, and state restrictions. On number 2, I hope you quickly realize that in the numerator there's a GCF of 6x, and so we're going to factor that 6x out, leaving me with x plus 1 in the numerator. In the denominator I have a 3x. The values in the denominator that will make this equal to 0 are 0 itself, so x cannot be 0 as a restriction. Then we look at what's going to cancel. One of the x's cancels, and the 6 and the 3 cancel to the 2 in the numerator. That's going to leave me an answer of 2 parentheses x plus 1. So here's just very simple: factor, cancel, and then state your restrictions. In our second part, we're going to involve multiplying to our problems, and realize when you are multiplying, you can cancel anything with the numerator of either fraction with anything in the denominator of either fraction. So we're going to have a little bit of careful canceling here. The 6 and the 8, we're going to divide them both by 2, leaving me with a 3 and a 4. The x cubed and the x, we're going to cancel out to be just x squared. The y and the y squared are going to cancel to be just a single y. And the 5 and the 15 are going to cancel to a 3 in the numerator. At this point, I think it's safe to say that the problem that remains is fairly intricate because we've canceled a number of things. You're going to want to be very careful with this problem as you now multiply across the numerator. 3 times 3 is 9. X squared times x is x cubed, and then you have a y, and this is all over 4 as an answer. In terms of restrictions, we look to the original problem. The original problem had a y in the bottom, so y cannot be equal to 0, and an x in the bottom, so x cannot be equal to 0. So that's our answer and our restrictions. I'm going to really encourage you to write a little bit larger than normal for these problems, because when you're canceling and writing things above and below, it might have the potential to get fairly confusing. Let's look over at number 4. If we factor the numerator, 3x plus 5, factor the denominator, 2x plus 3, times, factor the difference of two squares, x plus 3, x minus 3, and then the bottom is 6x. Now let's start to cancel what we can. The x plus 3's cancel. The 3 and the 6 cancel to a 2. Nothing else cancels, so that's going to leave our answer as x plus 5 times x minus 3, and our denominator is going to be 4x. What are our restrictions? Let's look at our original problem once it is in factored form. We have an x plus 3 in the denominator. That means x cannot be equal to negative 3. We also have an x in the denominator here. That means x cannot be equal to 0. So those are our restrictions in our problem, and that's our final answer. Let's look down at example number 5. In example number 5, we have an x as a GCF in the original problem. So x times x plus 4. In the denominator, we have a 2 as a GCF, 2 times x plus 5. The numerator, we have a 5 as a GCF, 5 times x plus 5. And the denominator, we have 10x squared. Fairly obvious, I think, that the x plus 5's cancel. The 5 and the 10 cancel to a 2. The x and the x squared cancel to an x. That leaves the numerator with x plus 4. And that leaves the denominator with 4x squared. Please realize that the 4 in the numerator and the 4 in the denominator do not cancel because they're connected with a plus and then on the bottom with the times. In the original problem, we had an x plus 5 as the denominator. That means x cannot be equal to negative 5. And we had 10x squared. That means x cannot be equal to 0. So there's our restrictions when we're dealing with multiplying. In our third and final part tonight, we're going to take a look at part 3 where we're dividing each of our problems. I apologize, I've written these incorrectly on my notes here. This is supposed to be a division symbol. So we're going to change both of these to a division symbol, as well as down here. I'll make sure those are automatically changed in our original notes. So dividing by a fraction is equal to multiplying by the reciprocal. So I'm going to rewrite these problems immediately as multiplication problems. So times the 8y goes in the numerator, the 21x cubed goes in the denominator. Now we're going to cancel whatever's possible. Here you see the x and the x cubed cancel to x squared. The 8 and the 4 cancel to a 2. The y cubed and the y cancel to a y squared. The 7 and the 21 cancel to a 3 in the denominator. That's canceled everything. So that leaves us with a numerator of 2 and a denominator of 6x squared y squared. Our original problem had a y cubed in the denominator. So that means y cannot be equal to 0. It also had now an x cubed in the denominator right here. That means x cannot be equal to 0 as well. And you may say, but the x is in the numerator up here. Why is that a restriction? Well, we really have 7x divided by 4y cubed all over 21x cubed over 8y. And if this value of x was equal to 0, we would be dividing the numerator by 0. And so we have to also consider that piece as a possible restriction. Let's look at number 7. We're going to factor as we do our problem. So we take a 6 out, x plus y, the denominator x minus y, times, take a 5 out, x minus y, notice we flip that to multiply by the reciprocal, and an 18. What's going to cancel here? The x minus y's. The 6 and the 18 cancel to a 3. That leaves us an answer of 5 parentheses x plus y over 3. What are my restrictions? Well, from the original problem right here, we get x cannot be equal to y. Then we have to look at our other problems. Are there any other restrictions? Well, this x plus y is in the numerator and stays in the numerator, and there's no values over here that will give us another restriction. So that's it for our restrictions there. X cannot just equal to y. Let's take a look at our last problem. We're going to start by factoring the denominator. So we have x squared in the numerator. The denominator, I hope you see it's a plus and a plus. 2 x's, and they're both going to be 1's. Times, that's the difference of 2 squares, so x plus 1 and x minus 1 over 3x. Now we're going to cancel. The x squareds and the x cancel to just an x. The x plus 1's cancel. And I think that's all that's going to cancel. So that's going to leave us an answer of x times x minus 1 over 3 times x plus 1. Now let's examine what our restrictions are. The original denominator here has x not being able to be equal to negative 1. The original denominator here has x also not equal to positive 1. And then our new denominator down here has x not being equal to 0. So we have three restrictions because all three could give us an original problem that would be dividing by 0. So as we're reviewing this, our main idea is going to be factor, cancel those factors, and then state what values would make the denominator equal to 0. We have 9 problems for homework here in section 9.4, page 501, 2 through 18 even. I've copied them on the next page here to hopefully make it a little bit easier for you. Please make sure you use plenty of space, spreading this work out and making it very clear so you can cancel your factors and work it out very straightforward. I hope this has been helpful in explaining section 9.4.